Hello and welcome to today's session. In the last session, you all have seen the working and the construction of the depletion type MOSFETs. In this session, you will all going to see the working of the construction and the working of the enhancement type MOSFET. So let us quickly jump onto the constructional diagram and let us see how it looks like. So now you can see here the construction of the enhancement type MOSFET. So the main difference which you can see from this and the depletion type MOSFET is that the same substrate, here we are talking about the N channel enhancement type MOSFET. So the base substrate will be of P type material on which we are going to diffuse the two N type materials. So this, that is N type material, here as well as on the other side. So this acts as a source and this acts as a drain. So this might be lightly doped and the drain might be heavily doped. But one important thing which you have to notice is that there is no channel, there is no formation of the channel during the construction. So if we can see quickly from these diagrams, so if you see from this depletion type diagram which we have seen before, there is an existence of the channel between the source and drain, but when we see here in the enhancement type there is no channel at all. So it means if I just connect my VDS, so let us connect the VDS supply here. Yes, so I'll connect the positive potential to the drain. Sorry, let me clear this section. So if I connect this, so if I connect a positive potential to the drain and negative potential to the source, so that will make supposed to make the MOSFET to work. It means there's supposed to be a graph where as we increase the VDS, so this is our VDS. As I increase the VDS, there's supposed to be the flow of current, and at some point it leads to saturation. But here, due to the absence of channel, so what's happening is, so we cannot see the, due to the absence of channel, there is no flow of current at all because there is no path for the current to flow from source to drain. So it means the MOSFET initially it will be in the off mode until unless we'll apply the gate voltage. So this is the main difference between the depletion type MOSFET and the enhancement type MOSFET. In enhancement type MOSFET we have to apply the gate voltage to make it off, but whereas in the enhancement type we have to apply the gate voltage to make it on. So this is the basic difference between the two types of MOSFETs. So now how the current will flow, so let us see. So here let us apply the bias to the gate. So here we will apply the positive potential to the gate. We do not apply the negative potential because there is no point in applying the negative potential. So since I applied the positive potential, what happens? So due to this positive potential, an electric field is exerted, and here the main substrate is of P type. So this positive, due to this positive polarity, the majority carriers get repelled. So what are the majority carriers here? The holes are the majority carriers here, so that get repelled and it will come across. And the minority carriers or the electrons, it starts accumulating near this SiO2 layer. It will not cross this because the gate is isolated by SiO2 layer. These electrons will not jump into the gate terminal. It will not flow through the gate terminal. Because of the isolation, it will start forming a minority carrier charges. So this formation of these negative or the minority charge carriers will form the gate. So now as you apply the voltage, the gate voltage higher and higher, the width of this gate also increases, means there is a formation of the higher and higher minority charge carriers near this SiO2 layer. So as we can say this, so now I can say there is a formation of the channel, and now the current flows from source to drain. So if you look into the characteristic graph of this, so if you see the characteristic graph, So this is our VDS and this is our ID. So initially when VGS is 0, when VGS is equal to 0 volts, it means there is no flow of current. When you apply the slight VGS, so what happens, you will get a graph like this. So where this is the for VGS equals plus 1 volts. Remember, this is plus 1 volt, it is not minus 1 volt. So likewise, as you increase the VGS, the flow of current also increase and get saturated to higher and higher values. So this is for VGS equals plus 2 volts. Okay, so likewise when you increase this higher and higher, so here also you will get the higher current and it gets saturated for the higher values. So this is say VGS for 3 volts. So likewise it keep on increasing. So let me write this. So this side we call it as the saturated region or the saturation region, and this is we call it as ohmic region. So this is how the graph looks like. So here as the VGS increases, the current saturation level also increases. So this is the basic construction diagram and the working of enhancement type MOSFET. So hope you have understood this diagram. So the main thing which you have to note here is the absence of the channel during the formation or the construction of the enhancement type MOSFET. And how do we create the channel? To create the channel, we have to apply the positive gate voltage. So due to this positive potential, what happens, the majority carriers get repelled and minority carriers starts accumulating near this SiO2 layer. So here, and that forms the channel and that forms the path for the current to flow from source to drain. So based on the VDS voltage, the current starts flowing. As you apply the higher and higher VDS, the current flows and gets saturated to the certain level. So as you can see from the characteristic graph, the output characteristic graph for VGS 0, the device will be off, and as you apply the VGS higher and higher, the current starts flowing higher and higher and gets saturated to the higher values. Okay, so let me save this graph. Let me save this as page 9 here. So let us go to the new one. So now we will see the symbolic representation of this depletion type MOSFET and enhancement type MOSFET. So let me draw here. So this, and this. Okay, so this one, and this one. Right, so this is the gate, this is the source, and this is the drain. So now, and this is nothing but there is a one more lead to the substrate that we have not shown in the construction diagram. So when you see this substrate, so there will be a one more lead here at this point. So basically this is also connected to a gate, so there is nothing much to be worried. In most of the cases it will be internally shorted to the gate, to the source, sorry, and not to the gate, to the source, so we need not to worry about it. So this is the symbolic representation for the enhancement type N-channel enhancement type MOSFET. So here the arrow mark is inwards. So same thing if I write here. So it looks like this. Okay, so if the arrow mark is outside, so let me write here, this is of this is N-channel enhancement MOSFET, and this one is P P channel enhancement MOSFET. Okay, so this is the gate. Sorry, this is gate, this is source, this is drain. So let me quickly write the symbolic representation of depletion type MOSFET, then I'll explain this, the basic difference between the two. So here also for N channel, it's the arrow mark is inside, and for P channel it is outside. So this is your source, sorry, that is your gate, source, and this is drain. This is your source, this is gate and drain. So again, this is N channel. So this is N channel depletion MOSFET, and this one is P channel depletion MOSFET. Okay, so if you see the basic difference between the two, it clearly represents based on the construction. So this broken line here that represents, see, the gate is not directly connected to the channel, so that is why this gap between these lines represents there is an isolation. So this isolation is nothing but SiO2, and here this broken line represents the channel is not formed during the construction, whereas in depletion type here there is no broken line. So this represents the channel is formed during the construction. So this is the, so every symbol has its unique explanation, so that is why the symbols are formed with the proper meaning. And the arrow mark inside represents the current that these electrons are entering, whereas here the P type, you can see that the electrons are leaving, or you can see that it's a P channel representation. Okay, so this is a basic symbolic representation of enhancement type MOSFET and depletion type MOSFET. So hope you have enjoyed the session. Thank you for watching. We will catch you up in the next session of the CMOS construction and with a simple example diagram. Okay, thank you, take care.